Hello everyone, welcome back to my YouTube channel, and in today's episode I'm going to show you how to build an advanced RAG application that not only retrieves information and generates answers, but it also critiques itself through self-reflection. And all of this is aiming to avoid hallucination. So let's dive deep into this. Here in this diagram we have an adaptive RAG application that we will thoroughly discuss today. Let's assume a user has a question such as what's an agent, and let's see how the flow goes in this RAG application. So we will have a large language model that will route this question to either the vector store database aiming to retrieve relevant documents and then generate answers, or it will go directly to the web search to try to find this information. And for this purpose, we will need to use an agent. Let's assume that in this case, what's an agent, this question, it's in the vector store database. So let's take this path. So as a second step, you will need to build a retriever. And for this, we will need to use a text embedding model that will check the similarity between the question and the documents that we already have in the vector store database. And after identifying the documents which are the most similar to the question that the user asked, we will use a large language model that will take as an input the question and the filtered documents that were obtained through the retriever. And this large language model will have as an objective to grade the documents, whether they are relevant or they are not relevant. And that's what we have here. So the output will be either yes or not. If you're enjoying this content so far, don't forget to subscribe to the channel by clicking on this button because it helps me to create more content. Smash the like button and turn on the notification bell so you never miss a new video. So if the documents are not relevant, it will go to the web search, and we will use the agent here to try to identify documents which might have the information, relevant information, that will be used later on in the large language model to generate an answer. So in this case, in the web search, we will aim to find this information and we will append this information to the vector store database. But let's say that the information is relevant, so the filtered documents obtained from the retriever were relevant, we will go through this path and we will generate an answer. So we will have a large language model that will generate an answer. That will be the only purpose of this large language model. It will take as an input a question and the filtered documents, and the output will be a generated answer. So this answer that is generated by this large language model will be checked by another large language model that will criticize whether this answer is correct or not, and will aim to avoid hallucination, as I mentioned earlier. This is the whole point of using this adaptive RAG, to avoid hallucination at all costs. We will have a large language model just focusing on identifying hallucination. It will take as an input all the filtered documents that were obtained from the vector store database that were similar to the question and the generated answer from the previous node. And it will check whether this response aligns and is supported by the facts that were obtained from the filtered documents, basically. If the answer generated by the large language model is not supported by the filtered documents, it will go back and generate a different answer. And this loop will continue until it obtains an answer considered as false. So if the answer is proved by the large language model, which means that the answer is supported by the facts of the documents, it will proceed to the next step, which will be to check whether the answer aligns with the question. If that's the case, that will be the final answer. Otherwise, it will go back to the web search and continue the loop until it gets a final answer that is aligned with the question. And we will see how we can do this in Python now. Here in Python, I already created a virtual environment with all these Python libraries installed, and I already have a .env file with these credentials that you will need if you want to run this application. So let's check the code now. First step, we will need to load all our credentials. So let's do it now. Let's get the environment variable values of Tavily, which we will use for the agent, Google because we use a text embedding from Google, and GROQ for the large language model. Now that we have the values, let's proceed to create the first node, which routes, as I explained earlier, whether to go to the vector store database to find the relevant documents or to go to the web search. So we will be focusing first on the routing. Here we have it. So we will specify that we want to go either to the vector store or to a web search, and we need to specify specify in this description, given a user question, just to route it to web search or a vector store. So that's basically what we want to do in the first node. We load the large language model. We specify in this case temperature equals 0 because we didn't want any creativity, but you could change this value. And then we change the output of the large language model, because the whole point of using this route query here is to change the structure of the output, because we want to know whether it's a vector store or a web search. So basically the response of this large language model will always be either vector store or web search. And then we specify a prompt in which we say you're an expert at routing a user question to a vector store or web search. Here we're basically defining, as I said, to either go to the vector store or to the web search based on the information. In this case, I'm specifying that the vector store contains documents related to agents, prompt engineering, and adversarial attacks. And if the question is related to the agent, it will go directly to the vector store because it's already here, this word. In this case, let's say that I'm asking a question related to the NFL, we could see that the response will be to go to the web search, because in the system, in the prompt, we don't specify that the vector store database has information related to NFL or football. So let's execute this, and you will see that in the first one, if we use this large language model, it will return as a statement to go to the web search. And in the second one that talks about agent memory, it will go to the vector store. And now that we define this node, we can proceed to create the second step, which is a retriever, which will aim to retrieve documents from the vector store database. In this moment, the vector store database is empty because we haven't saved any documents there yet. So that's exactly what we do here. We take a couple of URLs which talk about agents, prompt engineering, and so on. We take these URLs and we save the content of these URLs in a vector store database. For this purpose, we're using Chroma, and the embeddings, the text embeddings that we are generating of this text are based on this Google model. And here we can create a retriever of the vector store database that we can use later on to get relevant documents to the question. Now that we have our retriever created, we can proceed to work in the third node. We have here a large language model that will grade the documents, whether they are relevant or not. Here we have a grade documents class, which will have as an output a binary score, whether it's yes or no. And we want to specify whether the documents are relevant to this question. So we use the same large language model, but in this case with a different structure on the output, because in this case it will generate whether it's yes or no. Here, as the template, we specify that the large language model is a grader assessing the relevance of the retrieved documents. If the document contains keywords or semantic meaning to the question, grade it as relevant, giving this an answer of a yes. Otherwise, give it as a no. And that's basically what we specify here. So here we create the chain that will have the grade prompt and the large language model. In this case, I'm giving as an example. Let's ask a question such as agent memory, and the answer is yes. So it's basically identifying that these words are contained on the documents that were retrieved as relevant. So if we go back to the diagram, we can see that we already created this large language model that will check whether the information is contained in the documents. So let's go back to the code, and here we have the large language model that will generate the answer. So we specify you're an assistant for question answering tasks. We will specify a question and the context, which will be the filter document. And here we have our LangChain, which will use this prompt, the large language model that we're working on, and a string output parser, just for the formatting of the output of the large language model. And then we can invoke this LangChain by providing the context, which will be the filter documents and the question. And this RAG will basically generate an answer. And that will be the whole purpose of this large language model. And then we need to create another large language model just to focus on the response and see whether it's hallucinating or not. Let's proceed to do it now. We create a different class here, and here we need to specify that we want as an output whether it's a yes or no. And basically the large language model will assess whether the generated answer is supported by a set of retrieved facts. And the retrieved facts will be the filter documents that we will feed to the model. And here we have a chain with the prompt and the large language model response. The prompt is the set of facts, which are the filter documents retrieved from the vector store database. And here we have the generated answer. And then in the response of the large language model, we will have a binary score. If it's yes, it's because the answer is supported by the documents, by the facts, and no if it's not supported. Here, let's see the results. So we can see here that the grade hallucination binary score, it's not hallucinating. And if we check the graph, if the answer is supported by the facts, we can proceed to check whether the answer aligns with the question. Here we have our final node, which is the grade answer. Here we specify a binary score, whether it's yes or no, and we specify you're a grader assessing whether an answer addresses or resolves a question. Give a binary score yes or no, and yes means that the answer resolves the question. Here in this chain we have the prompt, which is the user question, and the generated answer, and that's basically what we want to validate and assess, whether it can solve this question or not. And in this case, we can see that the grade answer is binary score equal no. And if that's the case, the answer does not resolve the question, it will go back to the web search. And if we use the web search, we will need to find this information using the agent. And that's the whole purpose of using Tavily. And here we have Tavily. We will try to find the top 3 results. And now we will use LangGraph to assemble all the nodes and edges of this flow diagram. So first we'll need to specify a graph state, which will be the input and output that we will use throughout this system, which are the question, the generated answer, the web search, and the document. Here I already created the functions to design the flow diagram. I will be leaving all the code in the description below, so you can check all this code in details later on. And then here I have the workflow that will connect the nodes and the edges. So here I'm just defining the nodes, which are the web search, the retriever, the grade documents, and the generate answers. I'm connecting the edges between the web search and the generate, and also the retriever with the grade documents. And then here I'm connecting the entry point on the route question to either go to the web search and the vector store. Also here I create a conditional edge that will decide to generate the information right away or to go to the web search to find the information when the documents are not found relevant. And here we have the final steps in which we check if the answer is supported by the facts, by the filtered documents that we obtained from the vector store database. And if that's the case, it will check if the answer aligns to the question. If it's true, it will end with the final answer. Otherwise, it will go back to the web search to find more information. So if we run this, let's ask this question to the large language model, which are the types of memory of an agent, and then we execute this code. We can see that it's routing the question to the vector store database, because we have in the vector store information about the memories of an agent, and then we see that it's checking the relevant documents and it's grading them, and it finds all of them as relevant. Then it generates the answer and it's checking now for hallucination. We can see here that the output is finally printed out. After checking for hallucination, it validates that the answer generated aligns with the question. And we can see here that the types of memory of an agent are short-term and long-term, which is amazing. So we can see how this adaptive RAG application is working as expected. Let's ask a different question this time, but this question will be unrelated to agents or any type of information that we have in the vector store database. So you can see how the question will be routed to the web search. So let's ask who was selected as the first pick in the draft in 2023 in the NBA. So let's check the results. Here we can see that the question is routed directly to the web search, which is supposed to happen because in the vector store we just have information related to agents and adversarial attacks and so on. And here we can see that the question was routed to the web search, and then it generates the answer, it checks for hallucination, and then it grades whether the answer generated aligns with the information retrieved. Here we can see that the response is correct. Here we can see that the first pick was Victor. And we can see that the flow diagram that we just constructed worked as expected, which is amazing. So with this flow diagram, we are able to create a RAG application that critiques itself through self-reflection. It checks whether the answer generated correct or it is hallucinating. Then it validates if the answer aligns with the question, which is amazing. And that was it for today. I hope you liked this video. If you have any type of questions, please leave them in the comment section below. Don't forget to subscribe to the channel because it helps me to keep creating more and more content. Smash the like button below and turn on the notification bell so you can know when I upload a new video. See you next week.